This video is an introduction to trigonometry for right triangles. So we are going to identify a reference angle given a side of a triangle, write trig ratios with right triangles, and compare and contrast the sine and cosine of the complementary angles of a right triangle. So the reference angle is the angle in which the problem is being based on. For a reference angle, we cannot use a right angle, but we can use either of the other two angles. So let's say that angle D, in this case, is going to be our reference angle. Then, based off that angle, we can label our three sides. So the opposite side is the leg that is opposite from the reference angle. So if I go from the reference angle and I drag my pen or pencil across the paper to the other side, this is our opposite leg. The adjacent leg is the leg that is next to the reference angle. It is not the hypotenuse. So remember that the hypotenuse is across from the right angle, so the side that's not across from the right angle is our adjacent leg. And then our hypotenuse is the longest side of the triangle, and it's always across from the right angle. So what I usually do is I label my opposite side and my hypotenuse first, and then the third side has to be the adjacent side. So given the reference angle, label the sides of the triangle as opposite, adjacent, or hypotenuse. So if we have angle B as our reference angle, our opposite side is across from it. Our hypotenuse is across from the right angle, and the remaining side is the adjacent. If R is the reference angle, the opposite side, the side across from the right angle is the hypotenuse, and then the third side is the adjacent side. So given triangle BIK, we need to name the leg of the triangle that's opposite of angle B. So if angle B is up here, the opposite side would be IK. Remember to put your segment bar above that. We also have K. So the side opposite of K then is BI. The hypotenuse is not going to change no matter what angle, so it's always across from the right angle, which in this case is BK. In number 3, we have triangle SKT, so we want the side adjacent to it. So there are two sides that are next to angle S, but we want the side that's not the hypotenuse, so we would have SK. Same thing when we have angle T. We want the side that's not the hypotenuse that's next to angle T, which would be TK. Our hypotenuse is still going to be across from the right angle as ST. Number 4, given triangle WLK, we want to name the angle if the opposite side is LW. So if this side is LW, the opposite angle would be angle K. The adjacent angle is the one next to it then, so angle W. We wouldn't say angle L because we don't want the right angle as a reference angle. If we have the adjacent leg to KL, so the angle next to it is angle K, which means the angle opposite of it would be angle W. So when we use trig ratios, we are using ratios that involve two sides of a right triangle. We have 3 trig ratios: sine, cosine, and tangent. So sine, if we have D as our reference angle, is going to be the opposite side over the hypotenuse. Cosine is going to be the length of the adjacent side over the hypotenuse. And tangent is going to be the opposite side over the adjacent side. It's important that we know these ratios and we set them up correctly, or we will be solving the problem wrong. A way to help us remember is SOHCAHTOA. So sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So let's use these to find our ratios. So we have a triangle here. We're going to start looking at angle A. So if angle A is our reference angle, remember that sine is opposite over hypotenuse, so the opposite side length is 15. The hypotenuse is 17, because we can always label our sides. So For cosine, we have adjacent over hypotenuse. So the adjacent side is 8, the hypotenuse is 17. And then our last one for tangent, the opposite over the adjacent. So the opposite side of A is 15, the adjacent side is 8. When we switch our reference angle and we switch it to angle C, the opposite and the adjacent sides are going to switch, but your hypotenuse will stay the same. So for the sine of angle C, it's still opposite over hypotenuse. We have 8 over 17. For cosine, it's adjacent over hypotenuse, so 15 over 17. And then for tangent, it's opposite over adjacent. So in this problem, we have the sine of A equals the cosine of B. So if I label my triangles with just 3 random letters to look at the ratio, we have X, Y, and Z. So the sine of A is your opposite side over your hypotenuse. The cosine is the adjacent side over the hypotenuse. Notice that they have the same ratio. So because this is true and they have the same ratio, the angles are going to have a relationship. Now, in a right triangle, we already have a 90-degree angle. So the other two angles also have to equal 90. So the measure of angle A plus the measure of angle B has to equal 90 degrees. The angles are not congruent. That is a mistake a lot of people make. Remember that they are complementary, which means they equal 90. So let's look at a few examples. So in number 6, we want to take our two angles, add them together, and set it equal to 90. So we get 9x equals 90, x is 10. In number 7, when we take our two angles. Now it doesn't matter if sine or cosine is written first or second, they are still equal. So we have 5x plus 20 is equal to 7x minus 2 equals 90. So we have 12x plus 18 equals 90. 12x equals 72, so x is 6. In number 8, the trig ratios are equal, so the angles together equal 90. So we get 9x minus 9 equals 90, 9x equals 99, so x is 11. And the last one, again, our angles together equal 90, so 6x plus 2 plus 16x equals 90. We get 22x plus 2 equals 90, 22x equals 88, so x equals 4.